So yeah, we're gonna do some materials today, and then we're gonna get into dynamic instance materials, so you guys can see. Maybe we can make something glow and then unglow. That might be useful for somebody's project, you know. So there you go. And then we'll put it on. Then I'm gonna show you guys how to network your software over UDP to other softwares, so that you can then drive things from heart rate or my phone or whatever, and that really extends Unreal really as an installation software, not just a video game or a VR making software. So there's a few. So we're gonna start with making materials, and we're just gonna make them from images that we find on the internet. And there's a couple of programs. This one right here is Crazy Bump. Um, Substance Designer makes Algorithmic makes a product called uh, Bitmap to Material. It has a lot more features. As a student, you can get it for free, but it might be Windows only. So now we have one for Mac, but now we have one for Windows. This was a lot of features. It helps like randomize the tiling of things. You can add in procedural grunge and all this other kind of really lovely stuff. If you guys are interested in making amazing textures and materials, definitely look into the software Substance Painter and Designer. They plug into Unreal, and like Substance Painter is like you can bring an object, you can like spray paint it, and like it's a great way of giving hand drawn looks or handcrafted looks to some of these characters. And yeah, as I said, as a student, you can get them for free. But we're gonna do Crazy Monk since I have it already installed on my computer. We're gonna get an image from the internet, and the key of term is we want to make sure it's tileable. We want to make sure that it has a seamless edge as it repeats across our object. Um, you can also do this in Photoshop. It's a little bit more time consuming than I want to do right now. So we're just gonna go ahead and find one that's tileable, and maybe like rock, and then tileable. Is the internet slow? Maybe you have something. Okay, there we go. Images. And this is kind of an older convention, but it's called the powers of two. Usually, texture files for easy storage were kept at like 512 by 512 in pixels, 1024 by 1024, 2K and 4K on and on. It's not as important, but it's still a convention that most people adhere to. Just makes it uniform using squares. It's easier to analyze. I am not going to let my demo be slowed down by internet. Let's figure this out another way. NYU. And that is motion. All right. So, well, now it's up. Let's find ourselves a cool tileable rock. Great, great. I can't really tell if any of them are. So we're just gonna go for it. So seamless textures. Okay, great. This is 1600 by 1600, and we're going to view it and drag it to my downloads. All right. Fantastic. Downloads. And then we're going to open it up into Crazy Bump. I'm going to open a photograph from a file. My downloads. And it's called Mountain Rock. Cool. So now it's thinking about it, and what it's doing is it's trying to figure out the normals. The normals are this beautiful pink and purple layer of texture that is it talks about how light is reflecting off of an object. It helps create shadows. Some people actually say that it's not very effective in VR because of your positional tracking. You can actually break the effect that UVs give you. So it's one of those things that people are actually like actively debating whether or not UVs are as effective. But we're going to go ahead and use them just so you know the full workflow for using outside of VR as well. You can see right here on the right, it looks like the rocks are kind of jutting out here. and on the left side looks like they're being indented in. Which way do we want to go? I know that I always choose the wrong way, so let's choose the wrong way. And there is this texture. See how this is just from an image on the internet. We now have this way of kind of making something seem a little bit more 3D. Instead of having to model this texture in there with like making a whole bunch of high density polygons, we now have given it a texture, even though it's like basically a six-sided, six-polygon object. So it gives us a lot of bang for our buck. And there's a lot of settings you could do on all these. We have normals, which are here again, what's creating that depth illusion, and then we have specularity, like this is how the light glints off of it, and then we have the normal regular color. So it gives us a bunch of different materials or textures that we can combine together to make a physically based rendered material. And then I have all sorts of settings. I just use the default. So I'm going to save. I want to save all of them. Save normals. So I guess if he makes us pay for Crazy Bump now, he's not like making it phone home or anything. He's just making Mark pay. Mark, that guy's not cool, man. Don't let him treat like that. All right, so I'm done here. That was fun, and I'm going to make a folder for textures and bring them in. And I can just drag it into the content browser. You see, sometimes you have to like hold it over and hover. Just don't be discouraged. Sometimes you have to like wait a second and then it'll import, and sometimes no, at all. You know, add in the old standard way. Mm-hmm. You can't do VR, but it works fine in that. Yeah. Do you say nice things to it? Do you treat it right? Yeah, you know, yeah. So I have all these textures, and I'm going to create a material from scratch by right-clicking here, and I'm just going to the convention is to give it a prepend like an M first for material. That's just we work with other people. This is kind of what they end up doing. So M rock. All right, and we'll just drag all those suckers inside of there. Hey, come back. All right. And now let's hook it up in the most sensible way possible. Let's see. They're given little names, and they should correlate to the things over here on the right. We have, first of all, this one is the first texture that I started with, and it's going to be our base color. All right. Then this one is called displacement. So we're not going to use this one just yet. I want to kind of show something with it. We have specular. That was from here. I'm looking right here at the text, and it says SP at the end, so it's the specular one we downloaded. This one is ambient occlusion. This is like baking in shadows, which makes it a little bit nicer, not having to compute those shadows in real time, which actually don't exist because they're faked by the normals. And then we're going to go into the normals. And let's go ahead and save and let it compile the shader. Cool. So now we have like this rock thing. And it looks really nice. And it's tileable a little bit. So let's throw it on something. Let's put it to work. I want to have a rock table. Just gonna drag it on. All right, rock chairs. It's like an episode of Flintstones. Everything is rock. And so give it a second. On a PC, the bottom right would say compiling shaders. It's not doing it here, but it is. That's why it's thinking. I'm going to go ahead and save all. Cool. This is my new lawn furniture, guys. Pretty darn cool. So that was a pretty good bang for my buck, you know, just free file from the internet, and now we have a whole themed patio set. Cool. So let's get into some other features of let's make some more materials. One of my favorite ones for my motion capture class is like this one called that's a Fresnel. A Fresnel is a kind of extremely thin lens, and only when you see it from its side, you can see through it all the way, except for when you see it from its side. When you have a thickness to the glass, can you actually see the material itself? So basically, it's a gradient, and that's kind of built in to Unreal. If I look over here on the left side, you see that it has these different parameters. We have 5 for the exponent and base reflect, fraction, point of 4. I'm just going to leave this all what it is. I just want to take this for now, and I'm going to take 2 different materials. I'm going to do black and white first, so I don't even need to use RGB. I could just say 1 and 0. So I have a constant for 1, and I have a constant for 0. And I am going to interpolate through them. That's for those of you who like to do your coding, it's a linear interpolation is a LERP. And it just means that like the alpha. It's like the crossfade parameter. So we have one, and we have the other, and then we want to interpolate through them. We want to crossfade between them. And let's make this in the emissive. So it's going to glow eventually. Yes.
So, LERPs, linear interpolations, right?
Yeah, it's crossfading. It's from A to B.
So it's like blend shapes in Maya.
Mm-hmm.
You use them. How do you animate them then? Or not animate, but how do you?
The alpha is what you usually animate. That would be a value from 0 to 1. But because I'm using a Fresnel, it's kind of an algorithm being driven in there. So let's, I'm going back. Sorry, the yeah. So you have yeah. So that's the default parameters right here. I overrode them with constants. Yeah. So the default settings of a lot of things are already built in. Like just like this Fresnel has a built-in setting right here on the details panel. LERP does as well. So this means that 0 and 1 and halfway between 0 and 1 is 0.5. So this is basically going to be gray if I plugged it in. So this is like a kind of an off-white. This is a gray. It's halfway between 1 and 0. And the question was, how do I get a LERP what? Yeah, so if I press down 1 with my on my keyboard and then click, I have a constant. If I hold down 2, I have 2, and then if I want a 3-vec like an RGB, I hold down 3 and I click, and I have an RG and a B. Like if I double click on this one right here, this is actually a color value. So this is just it's vectors, using vectors for color. So this is now blue. And so now I'm going to plug back in, let's put in the LERP again. Let's take a look at this Fresnel thing. And I'm going to switch it real quick. Cool. See this? So you can see the edges. It's like a really thin material that you can only see it when you're looking at it from the edge. This being able to render this in real time is kind of like a huge thing. So this can also be, so it's emissive, but it can also be, so this is the color. We can also make it the alpha. I'm going to take this blend mode and I'm going to make it translucent, and I'm going to drive this into the opacity as well. So where it's the grayscale value where it's black will be transparent, and where the grayscale value is white will be opaque, but it'll be a gradient. So there we go. This is really cool on like characters to make them look ghostly. But it can also just be colors as well. We could take away the opacity, and I can plug in 2 different colors. And I'm going to Alt drag. No, it doesn't work. Control W is duplicate. Let's do blue and let's do pinkish. Fuchsia, I guess this would be fuchsia. Let's see what happens here. Cool, look at that. Right? These are super awesome. But let's say I want it also to be have opacity as well. But opacity isn't really driven. Well, it could be driven, but it doesn't make sense to be driven from blue and pink. It should be back to this 0 and 1. So I'm just going to duplicate, Control W, this lerp, and then use this same Fresnel to drive opacity from the 1 to 0. Dun, 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 dun. Cool. So it's like it has a gradient of opacity and it has a gradient of color. So this is just kind of fun to like just drag your boxes and lines around and recombine them. The Fresnel settings, we could say, what is that exponent? It's a 5 by default. That's also, I'm going to press on 1 and give us a constant again. And I know that's 5, but let's try different colors and see what happens, or different values for this constant and see what happens. So right now we're giving it a 0. Probably should give it a 1 to start off with. Wait 5 minutes for the computer to catch up. And so this looks at basically it's the scaling of that gradient. You see this is a much longer gradient, whereas before we could only see the edge. This is now, that value seems to change that. So if I probably push up to 20, it'd be extremely thin line just around the edge, and this is giving us a little bit more color to play with. So materials are only fun and hypotheticals for so long before we need to actually just throw it into the world and see what it looks like. So let's go into the world. And let's see, well, obviously the statue needs to be a Fresnel. Think. Think. Alright, I'm bored of you. So I think we should also make the whole skybox. This whole skybox is a big giant circle surrounding us. Let's add Fresnel to that too. We're gonna turn this into, there you go. Look at that statue, looks pretty cool. I'm gonna save all just in case. Skybox. Can I not override my skybox? Let's see. Alright, let's. It's not gonna let me. That's fine. All right, so we've seen this Fresnel now, and we've talked about constants, but from those of you who've done a little bit of coding know that we can also have scalar parameters. So let's first of all show you a little bit more fun with the emissive. I'm going to hold down M and click, and it gives me multiply. And I want to multiply the color value by let's use this little constant real quick, because I have it here lined up, ready to use. So I'm taking the whole value, and let's crank it by 20. Make it 20 times more emissive. Think. Cool, so now it's a light source. Can I make this even brighter? Let's go for it. I'm willing to try. Cool. So now this guy, you can see he kind of has even more of a glow to him. And it's cool. So I want to be able to drive this. I know that somewhere between 20 and 100, but I'm not quite sure. And I want to be able to see my scene while I am looking at it so that I can dial it in correctly. So instead of making this a constant, we need to allocate some memory to it, being more dynamic. I'm going to right-click and say Convert to a Parameter. There we go. And the parameter, we give it a name so we can address it through our blueprints. This is going to be glow. I'm going to use all lowercase to keep it consistent. So glow is our parameter you see here. I named it over in the general details. All right, save. And its default is 100 for right now. And I guess while I'm at it, I'm going to also convert these 3 vectors, these colors, to parameters as well. So this is going to be outer. No, this is inner. I right-clicked on the constant, and the very top option is to convert it to a parameter. And now I can give it a name and a default setting, which we already have. This one right here. So that was just a constant right here that I right-clicked and I converted it to a parameter too. Yeah, all your constants can be converted to parameters. So you see, you just kind of like start building things out a little bit more complicated, and now we're going to play with this a little bit in the content browser. So we have 2 colors and a glow value that we can play with. But it's a parameter, but it's not. It's not been allocated to memory to be able to be driven in real time. It's not dynamic yet. So to do that, we need to create. And it's also just smart to create instances of our materials. And you might have seen this messing around with some of the packages that you can get and download and install. If I right-click, again, this is all context sensitive. If I right-click, the very top thing is create a material instance. Let's say this material is super complicated, and I want to have a bunch of different versions of it. Every version is a slightly different color. I can create a couple of instances, and this is what an instance looks like. And it has just the parameters that I made at the left. So I'm only dealing with these 3 items. I made those 3 parameters. And I can make this one be a different color. So I have to click it to make it available. This is putting it in the memory. Boom. And so now we have a green one. That's a beautiful gradient. Ooh. And I can now make another instance of this really complicated material, but I just want to change these few parameters. And then this one could have teal, and that one right there, red. Cool. And this one, I'm like, I don't really want it to be glowing so much, so let's bring it down. And you see that it's way quicker to render. I've told the engine that this is now a priority for me to render quickly. It's a dynamic instanced material. And so I could take this and just kind of pluck it off right here to the side, apply it to this object, and if I hit play, this is where you need two screens for sure. If I hit play, come over here, take a look, grab my mouse back, I can do this in real time. Maybe not in the Mac. Well, it can be done in real time, and maybe I'm not going to be able to do it with my mouse, because it really doesn't want me to. But I'll do it from a timeline, because I was showing people some timeline stuff. And it's a really effective tool for making things glow and unglow as you go towards them and away from them, or something like that. So I want to affect this parameter in real time. I'm going to do this all from level blueprints, just to kind of keep it as simple as possible. So let's go ahead and stop. This was I made an instance of the original material, and then I have these two instanced materials, and and they look differently. Maybe now that it's saved, I could have driven it in real time. Let's just try it real quick. It's important to save a lot. Nah, we'll do it in Blueprint. So I keep on talking about game engines and them being lazy. Like they don't want to really have to do collisions. They don't really want to have to process dynamic instance stuff. So we always need to tell it, hey, reserve energy for this kind of stuff. So that's the first thing we're going to do. We're going to go in our level blueprint. I'm going to grab this this vase. What is it called? Statue. It's definitely not vase. It's a statue. Because it's selected in my world outliner, when I right click, I can create a reference to it here. Way in there. And I want to create a dynamic material instance. We're gonna put this in and allocate memory for it. Great. And I want to do it on event begin play. I want to do it as soon as I start. Event begin play. The element index, we only have one material. Index 0 means it's the first material. We only have one material there. So it is just that one material. And then what is the material? Well, it's the Fresnel. Actually, let's find out what the instance is. I think it's instance 2 of the Fresnel. There you go. All right, so on event begin play, we're going to make sure that it's designated as a dynamic material. And then let's just make this into a little a variable. I'm going to right click and promote it to a variable called dynamic or dynamic material. Cool. So that'll work. And it's not going to prove much to us, but I'll go ahead and print string. So we can prove that that executed all the way through without an error. I hit play. It says, hello, top left. Okay. So now we need to drive that parameter. So let's find that parameter and we're gonna animate it. Let's go back to the blueprint. So we're gonna use this thing called a timeline. Yeah. Mm-hmm. It's a dynamic material, a material instance. I just right clicked on the return value and I just promoted to variable from there. Yeah. Yeah. cool. So, so this is the right material. Great. Oh, so we're gonna use this object called a timeline. If you right click at the very bottom, the very last thing, the timeline. And we call this glow. Doesn't really matter what you name it. And if I double click in there, this is a really simple way of having keyframes. You can do, I could do a float track. I could do vectors. That's a 3 if I want to drive the R, G, and the B. I can have an event track. So this could be a bunch of bangs that I send out and do different things on a timeline. And then you can also make it a color track. And the color track is cool because it's like a gradient thing where I have alpha, and I can drive actual linear colors and like make lights do things. Let's see. Add key. But this is not what I want to use. But you can just show you. So you can create this a color animation this way, and change like light colors and stuff. No, I just was showing a linear color track. What this one is a float track. This is going to be our glow value that we're just going to make it go up and down so that we can make it loop over and over again, and we're going to see that it goes up and then goes back down. That's all. So actually, I'll just make it go up. So we're going to right click and create a keyframe, and I'm going to dial in the exact settings I want. It starts at 0, and the value is going to start at, well, I think we're going to start at 20. It's nice. We'll start at 0. Start 0, 0. And then let's make it take 5 seconds. So the length of this track is going to be 5 seconds. Make a keyframe. Make it 100 at 5 seconds. And to get the whole thing in the view, we can use the 2 buttons to kind of fit it inside. Cool. And there's some other settings up here. We can have it autoplay, we can have it loop, we can have it do all these things. So like we can just to test this off before we do any kind of collisions or interactivity, we can just have it being looping and autoplaying. So it'll ramp up. Go root, root. So let's just see if that works to start off with, and then we'll make it interactive. So I didn't give it the track a name. This can also be called glow or glow amount. But let's just make sure that we can do that dynamic material first before we get too far. All right. So we want to pull this into something that's going to set a scalar parameter. Scalar meaning just a 1, not a vector parameter. So let's just right click and say set scalar parameter value. For material instance dynamic. That means this guy. Blink. We could have just put this up here too. Just kind of was messing around with making variables. All right, so this update continues to tick through the entire timeline. We're going to connect that here. We would also, it would give us a bang when it was done. If we wanted it to, every time it ends, to switch a different color or do some sort of other event. And we just need to connect the 2 floats for the values. And as you can probably guess, we need to actually make sure the parameter name is what is connected to the scalar parameter. Let's float, all lowercase. So let's see if this works. I don't see anything yet. So I'm going to switch over to, get my mouse back, and switch over to here. Seems to be running. Okay. It doesn't accept any of the source materials? Says what? So there's a couple of these different functions. You might not have gotten the right function. Target is a primitive component. This one right here, so that's got a parameter. Okay, so right click. Sometimes there is multiple, let's say set scalar. So you see there's two of them. I just did the first one. Oh, so you're saying this self and this. Okay, so the target is this variable. I can just easily do this. Or not even worry about variables and just do this. And then you have to type in glow manually. You just need one. Shunk. But I didn't even get it working yet, so we got to figure out what's going on. So the length is 5 seconds. Let's make this happen. I think I have them flipped. The time's supposed to be 5 seconds, not 100 seconds, and the value is supposed to be 100. There we go. That makes a little more sense. We all need sanity checks. All right, let's see if this is working. Yep. Cool. So we got it. We got it to work. We have it ramping up from 0 to 100. That's cool. Now we want to make it happen on. We want to trigger that. So I'm just going to grab just a standard trigger box. Box trigger, trigger volume, either would work. And we'll make it so when we get close to the table, it'll fire off. Where'd you go? Why are you over there? Why are you putting me over there? It's crazy. So we're going to walk over to the table and we'll watch the thing glow. Sounds good. So I'm going to have it. I have it selected here. I'm going to take off autoplay and loop. And now we're going to drive these things dynamically. I have the trigger box selected. I'm going to turn on context sensitive. You see there's events that I can have that are related to this trigger box now. And one of those is based off of collision right here. So all I have is just I have it selected in the world outliner. And I'm about to add a reference to either it or an event that's referencing it. And we want it to be when you begin overlap that we want this to play. We want to play from start. And then conversely, we want when we leave the trigger box, when we end overlapping the box, we want it to reverse from end. All right. You can tell my blueprint to say cheese for you. Cheese, cheese, cheese. You can't plug in this return value into the target. That to that. We'll take a break and I'll come over and do it with you. Cheese. So now I have a comment there and I can drag that cheese around. There we go. All right, so let's see if the trigger thing works. All right, walk in. Yep, there it went. Now go the other way. and then it comes back down. Cool. Go back up, come back out. I really can't see when that collision happens, so I just want to print string for this. You could only really do one thing coming out of execution pin. I'm going to use a flow control thing called the sequence. It lets me do two things on every tick. And the first one is going to be printing string, and it's going to say collide. And then in the same way, I'm going to put this on a sequence. And this one will just say, I'm gone. I'm no longer in the box. Play. All right, nothing. Now you see I hit collide, so now the animation is starting. It's glowing. And then I leave, and it's gone. It's coming back down to 0. Point. Yeah, so I made it 5 seconds inside that timeline. So the length of the timeline is totally up to us right here. Yeah. So, but you can kind of change the time. Yeah, Paul?
Is there a way to make it so that, let's say that you're close to it and you get the glow to the maximum glow that you want.
Mm-hmm.
And if that's the case, you want it to just stay that glow permanently.
Mm-hmm.
But if you didn't get it to 100 and then you left, it went back down.
Mm-hmm.
Is there a way to...
That's sort of like how like they do like the gaze interaction, right? Where like you have like a little circle when you're using a Google Cardboard and you look at a menu, and if it doesn't get all the way, then it comes back down. Yeah, so that's playing a little bit more with. Let me get back into the thing. That's playing a little bit more with playing and reversing, and only when it finishes does it go to another value. Yeah. So then you can create a boolean for it is now done, and it won't go back to reverse. So we're doing play from start and reverse from end. So it doesn't get all the way to the end when I was going in and out. So it's popping. That's just me playing around with the logic of all the execution pins on this timeline. It's an extremely powerful little thing that I thought was really interesting to show you guys. So that's great. We have this timeline. We could do this scale of parameter. This is kind of where I wanted to get us today. But I want to do one more thing. I want to make sure, I want to have this now out in the world. I want to be able to do anything and drive this parameter. So I am going to, we're going to talk about OSC messages. Have you guys done Open Sound Control in any of your classes before? Okay, so Open Sound Control is a framework that was built for Max MSP on what's called a UDP networking command. Way more complicated than all this is. This is just basically like the Hogwarts of what we do as interactive programmers. This is the stuff over the Wi-Fi that makes things happen. This is how videos are triggered at Madonna's concerts in Times Square. It was invented actually to replace MIDI. They were saying that in the early 90s they wanted all of this like mixing consoles, everything all run over Ethernet instead of MIDI cables because they thought it was cheaper and it could run longer distances and all that kind of stuff. And now it's not used for sound as much as it's used for video programming and interactive installations. And once you guys get a handle over OSC, then you can really see how Unreal can be an installation software, and you can really render out beautiful things and drive things with like Connect and drive things with audio reactivity. And that's what we're going to do right now. Is I'm going to make this glow be the sound of my voice. Is going to make this thing glow. All right. So I have my little favorite thing in the world, which is Max. If you haven't used Max before, it's extremely fun software made by company Cycling74, named after the father of computer music, Max Matthews. And I think its like slogan is like connect everything, and it does. It can connect your toaster to your printer to your CD player. Like literally, like I'm not even joking. Like this stuff does everything. And it has a visual component called Jitter that Luc Dubois, the co-director of this department, helped develop after he finished his PhD at Columbia Music, where he does, I don't know if you got the logo with turtle graphics. He drew a tree with turtle graphics for his PhD. It was really funny. Um, let's see. So where do we start? I already have it installed. Max is a fantastic piece of software that starts off with a blank slate. I love that. Who here has done Max? I see like one person. So this is new for everyone. Great. So Max is also data flow, just like Blueprints. All right. So all I want to do is it has a graphical interface and it makes driving interactivity very easy. It's things like up here on the top, we have all these different objects. These are the only objects we can use. And we have objects, we have messages, we have comments, toggles, buttons, numbers, and sliders. You got to have lots of sliders. So I'm just going to take a number. All right, I have a number. And maybe I'll take another number, and it's just data flow, but you don't have to compile it, which is awesome. And just things drive other things. So I'll make this bigger for you. Right? Things drive other things, right? This is a toggle that's going to be driving a button. It's just data flow, and it's a lot of fun. What I want to do is I want to send a single scalar parameter from Max to Unreal. And we're going to be doing that over UDP, or what's called OSC. There's a plugin that I've already compiled for you guys, and it will be in the demo section for you. But just so you know where to find it, it's called OSC UE4. Did I not type? Let's see one. OSC UE4. And internet says no. Right. That's cool. I already compiled it for you. And I made it for Windows and I made it for Mac. It's not cross-platform. You have to compile it. Demos. So OSC Windows. I'll just give you the one for 415. Under demos. And now I have to go to a Starbucks to do this for you guys. I'll get it to you before the end of the day. But for right now, I have it and I can show you using it. So I'm on a Mac and I'm using 415. I'm going to take this plugin. I'm going to copy it and just toss it in my downloads so I have it for later. There it is. No. All right. And then for Windows. Cool. And let's do this again. Wonk. I was getting too complicated. Just undo it here. Okay. So I'm going to take this project. I'm going to take this project and I'm going to go ahead and I'm going to close it real quick. I'm going to open up the Finder real quick just so I know where my project is. There we go. And I'm going to go to the root folder. So here's the project I was made. Here's the content folder. And I'm going to make a folder for plugins. All right. And then this OSC plugin that I just unpacked is going to go in there. And let's reopen the project. Oh, let's close it first. And then we'll reopen it. And while that's opening, let's go back over to Max real quick. So what we're doing is we're going to be sending over my my local host. We're not really sending over the network. This could be over a router. I have a router right here just in case we wanted to use it and we wanted to communicate with each other's computers, and that's totally really easy to do. But we're going to just send it locally, and just to show you what this object is, I'm going to be doing UDP. New object, which is right here. I'm just going to say UDP. I have to say it right. And I see there's a send and receive. So I have to send on my local host, which is on my own computer, and then I have to choose a port. Your computer has hundreds of thousands of ports. This is how like your software phones home and tells on you that you downloaded it illegally and pirated it and all that kind of stuff. You could sandbox and play around with ports between around 7,000 and 9,000 are usually reserved for creative coders. So we're going to use 8,000. It's what defaults in Unreal. And I'm going to be sending a number box to Unreal. But it's an internet protocol, so I need to send it on like a URL. And I'm just going to make it a URL called, see, I have to do that / like internet, and it's going to be called glow. That's all we're doing is numbers going into address, $signs are variables in Max, and then this is the extent to what we're going to do in Unreal for driving that scalar parameter. Just these three things right here. Okay, and then to show you that the plugin is existing, if I come over here to this plugins window, it's now here at the very bottom. OSC is plugged in, Open Sound Control is plugged in, and it's enabled. So now we should be able to access some special blueprints that weren't available to us before, and we're just going to receive data, and we're going to filter for that specific address, glow, and then we're going to change that parameter. I'm going to do this in an actor blueprint, so I'm going to leave this guy right here doing its thing. I'm going to make a new blueprint, actor. And it's going to be called BP statue. Blueprint BP, that's just like the standard way of creating blueprints. Is give it a BP at the beginning, and let's open it up. And I think we did this. We did blueprints, actor blueprints last week, where we saw as I build things out for the blueprint, if the blueprint is in my world, then you see that as I add things, it'll show up there as well. For instance, I'm going to add back in the statue, and we're going to go over creating the dynamic material again just to practice it together. So let's find the statue first of all. Let's find the content browser. There it's selected now. And with it selected in the content browser, there's a reference to it as a static mesh. So there's all this context-sensitive stuff in Unreal. If you select the things in the content browsers, then it'll know to import those things specifically. So I'm going to bring in the statue. And I now have a visual reference that I don't need this scene root, which is just an empty null that just sits there so we can see it as we move it around. So if I drag it up, it'll just like disappear. Boom. Okay. So let's give the statue my my special dynamic instance, which was called Fresnel. Fresnel number 2. Sounds like a perfume. But it's an audio reactive statue. So okay, there it is. And there it is. So this is the one that's driven by the timeline. And this one's going to be the sound of my voice. All right, so what we did before was on event begin play, we created a dynamic material instance. Create dynamic material instance for Fresnel 2. As soon as we start, as soon as we event begin play. Cool. And then I should make that a little variable that I can drag around. All right, and we're going to call this one glow or network glow or whatever we want to call it. Cool. Now, we've added in that plugin for OSC. That's now a component that we can add to this blueprint. Everything inside my world is an actor, and everything inside of blueprints are components that are on top of actors. And it says right there, add a component. These components could be trigger boxes and environmental elements and static meshes, skeletal meshes, but we want to just do OSC. And there's an OSC receiver right here. Cool. And then just like we did the overlap for the other glow, we want to create an event that's just called OSC receiving. I just right clicked on there and I'm going to add an event. And this is just the event is whenever I receive OSC, let's let it spit it out here. And we're used to the execution pin, so this will be, as it receives OSC, it'll be spitting out the execution pins. We know what the address is because we just made that in Max. It's glow. So let's add that in. We're just going to say equals. I'm going to put in /glow. And then my data. My data is we want to float, and the term for this is it's called popping a float. You can pop a bool, pop a blob, pop an int. All the kids are popping the blobs. It's pop and push. So we want to stack them back together, send it back to Max. We can say push blob, push bool, push int, all that stuff. String. A blob is like a more amorphous way of looking at data. It's kind of like it's a new thing for this plugin for this version to basically be more dynamic. It's like you can send more data that way. It just like packages it up, puts it in a garbage bag, sends it out. I don't know how to send a blob. Maybe that's something. Maybe that could be like a thesis project for you. All right, so you see this this equals has a red end to it. That's if I hover over it says Boolean. So we're actually going to drive an if statement. If on this channel, give me the float data. And an if statement in Unreal is called a branch. And the condition is going to be set true if it's on the channel. And now all we need to do is grab a reference to our material instance dynamic and say set scalar parameter. Cool, which was glow. The value is going to be there. And we're going to execute it. Okay, so the two things we did was we made sure that we've referenced the instance for the dynamic material instance, and then we're going to be receiving OSC data from Max. One other kind of important, there's two other kind of important things. One is we have to double check that our settings for the OSC, it's down here at the very bottom of your project settings. Just want to confirm that, yeah, it's receiving on 8,000. That's just like a sanity check. It doesn't matter what these ports are as long as they match. That's all. We're just sending data on a certain port on our computer. And then there's another kind of, I don't know if you guys have been using Unreal and had it rendering, and then you switched over to a website or something like that, and you saw that it got really, really choppy. It has a feature where it's trying to help out your poor computers, and it uses less CPU when it's not the frontmost application. I want to turn that off because Max is going to be in front, but I want to see real-time information. So that's just under miscellaneous here, and it says use less CPU in background. This is only a feature of using the editor. When you make a standalone application, it'll never do that. So just uncheck that. All right, save everything. And pull it to the side. And let's hit play. Let's hit play. There we go. And let's see if this does anything. So look at that. I have one piece of software driving another piece of software. Cool, right? So what do we want this to be? Well, I said it was going to be the sound of my voice. So let's do a little bit more Max. I'm just going to keep this the way it is because what's cool about Max is you don't have to compile. That's why I love using it for data flow, or the data flow nature of it for doing real-time interactivity, because I can change the scale of everything in real time and really dial things in. I often use Max to place items and scale items in my scene with like sliders and knobs from MIDI controllers while you're inside of VR. It's really useful to use OSC for this kind of detail work inside your stuff. So Max is great for audio. I'm going to convert my analog voice into a digital signal, and that's called an analog to digital converter. So a new object. Max will also try to autocomplete for you. So it's called a analog to digital converter. I'm going to do one that has a better graphical interface. It's called Easy Analog Digital Converter, and it looks like that. It's a microphone. Well, that's cool. And then I am going to, I want to look at my amplitude, and that's an object called, I'm going to look at the peak amplitude. So that's a thing called peak amplitude. There we go. And I'm going to pull it not every second. I'm going to do it like every 33 milliseconds. That's kind of like 30 frames per second. That's just a video kind of convention. And let's look at this number. Let's see what this would be. I'm going to turn it on. All right. Okay. We have real-time stuff. You know, I said there's sliders. We can put a slider here. Okay. Let's see. Let's see my data. Boom. Let's change the kind of slider it is. Whoa. I'm just gonna do. This is gonna be a all. I'm not gonna worry about it. Let's get rid of it. All right, so we can see we have numbers here, and it's going from like 0 to 0.2 pretty much. So I know that I want it to be like thousands. So I'm going to use a scale object, and it's called scale. So just new scale, and we're going to scale from 0 and 0.2, which is my low and high, and we're going to make a new low and high, which can be 0 to 10,000, whatever we want it to be. And you see this object just kind of dynamically changed. I can actually put number boxes in here and override these numbers in real time. That's what I was talking about. You can do things dynamically. I can say, oh, 10,000 is too much. If I put a number on the top of here, I can make it be less than 10,000 as I'm trying to find the right setting for it. But for right now, I'm just going to put data in, and then I'm going to put data out. Okay, now we have an audio reactive element inside of our scene. So that's pretty cool. So obviously this was kind of like I didn't know that no one knew Max. I thought this was kind of a house of Max. So I'm gonna do a lot less than that stuff, but I did want to show you guys that like this is small. This is one number, but this could be a lot of numbers. This could be a lot of data. This really gets this can be heart rate. This can be this can be positions from motion capture system. This can be all sorts of data. It can be anything now inside your VR experience. And you not only can have timelines, but you can have things. You can do show control. You can design each person's experience individually and have things flying around and doing things with your own performance. Yeah. Mm-hmm. Yeah, so this is just a floating point number, but I can send a bool. I can this toggle object that's right here. I can also put that on a channel, and it'd be a 1 and a 0, 1 and a 0, and that would also trigger animations. So you can do beat detection, and you can every time you cut a beat, then it would actually trigger the next animation. Mm-hmm.
And then obviously you do the opposite, where it's off, and then if you want to go box trigger, it starts.
Yeah, that's like you could then add the logic inside of Unreal that either you can allow it to be audio reactive once you get into a certain space.
And I don't think does Max just have everything. Like if you wanted, say, to like take a picture during your thing, like walk up to something that you see the camera, and then you walk into the up to the lens, it goes and saves the picture.
It would be easier if you did it with a webcam plugged to your computer.
If there was a webcam, this could actually take a picture.
This is how, I mean, like, there's so many, like, GIF spoofs that are made with Max. That's, like, it's all for video. It can record video. It can record video in a buffer. It does all sorts of interactive video components as well. Yeah.
Is all of this rely upon the C++ version?
No, I had to compile it with C++, but now it just worked for you guys. The Mac and Windows version could just be Blueprint only. Yeah, I wasn't sure if I was going to be able to. I didn't know if I wanted to compile it for you guys. I decided not to. That was a little bit too much for today. So you have a pre-compiled version that works with any project as long as the version numbers match up, and I give you 4.15. Yeah, yeah, yeah.
How does it export out?
How does
This whole, it's going to import this Unreal file. Would it still be audio reactive with connections and maps?
yeah? So like literally, if you made this into a Gear VR app, as long as you get the IP address of your phone and you send it to the phone, you can make the Gear VR experience audio reactive from whatever microphone is sending the data. So I use this to make at South by Southwest we had we were doing 10 people at a time simultaneously in Gear VRs, and I put start and stop and rewind on my phone, and and we were doing synchronized Gear VR by using this kind of this connectivity of OSC. So this is like literally, I say like this is the Hogwarts. This is the Hogwarts of the creative coding stuff. Like this magically sends data everywhere, and everyone's like, "How'd you do that?" And you're like, UDP. And you're like, what? Yeah, I have two different versions I've done on my YouTube channel. Yeah. So you guys can continue to make your own as you go to 4.16 and all that kind of stuff. Yeah. The repository. I mean, it's really easy. You just make the plugins folder. You put the thing in there, and you just open up a C++ project, and it compiles. It's not a hard thing at all. You have to have either Xcode or Visual Studio installed, but it doesn't actually open them up even. It just has to be there because it has to have these C++ libraries on your computer. That's it. There's no coding involved with compiling this. It's just knowing where to download and put things organizationally. So and this goes the other way, right? We can send data out of Unreal. So you can. So a lot of people in the motion capture class will use the skeletal information, and then they'll drive different instruments inside of Ableton, and then you're getting data out of Unreal back into things like Max and Ableton and that kind of stuff. So it goes both ways. So that's pretty cool. So that's all I want to demo today, and let's take a little bit of a break. I'm gonna finally have a sip of water, and then we'll come back and we're just gonna workshop, and you guys just have some questions ready for us so that we can help you out with your stuff. And I'll convert this video to a smaller file size, and I'll upload it to your demos channel and before the end of class today, so you have this for reference. All right.